Good evening and warm welcome to you all for the Tuzzle Smart Talk series Lecture 6 Structural Forensic Investigation of Concrete Structures by Dr. Nivin Philip, Professor, Department of Civil Engineering, St. Kitts College of Engineering. Tuzzle Smart Solutions LLP has gained widespread reputation as a civil engineering consulting firm in Kerala over past few years. The firm also design and project management services in road and building works. The firm also provides PMC services and laboratory services to contractors to aid them to keep quality aspects in control. The firm has a vision that academic industrial collaborations can help practicing engineers in more efficient and decision making. Smart Talk series is such an initiative to provide a knowledge sharing platform among engineers and academicians through interactions with eminent technocrats from academics and also industry. We cordially welcome all enthusiasts to our sixth session in the series organized in connotation with Association of Engineers Kerala, Thiruvananthapuram District Centre, Indian Concrete Institute, and Hybtech Total Solution providers about structural forensic investigation by an eminent and young engineer who is also an academician and an industry expert in the sector. Now, I request Engineer Jiju, Assistant Engineer, RKI and District Representative of Association of Engineers Kerala, Trivandrum Center, AOEK, to deliver a few words about the organization.
Good evening, everyone. On behalf of the organization, Association of Engineers Kerala, I thank you all for joining us today. Association of Engineers Kerala is a non-profit organization of about 4,000 plus engineers from Public Works, Irrigation and Local Self-Government Department of Government of Kerala. Every year, we conduct technical sessions to update our engineers about new technologies. We also conduct annual sports and cultural meet for the serving and retired engineers and their family members. The association encourages research and free discussion on engineering problems we are facing. And we publish periodicals containing articles by engineers regarding technical and non-technical subjects. This is our sixth technical session of this year. On behalf of Trivandrum District Committee, I congratulate the organizers for Turtle Smart Solutions for conducting this event, and I am very glad to be a part of this event. I also express our gratitude on behalf of AOK to Dr. Nivin Philip for taking his precious time to share his valuable knowledge and with experience with the engineers. Thank you.
Thank you, Jidin sir. Now I request Engineer Anwar Hussain, Chairman ICI Thiruvananthapuram Center and Director Hybtech, to deliver a few words about ICI and Hybtech. Sir, you are muted. Can you unmute?
Thank you. Indian Concrete Institute is one of the leading professional bodies in India, catering to the professional needs of individuals and organizations involved in concrete. Being a non-profit organization, it is dedicated to the cause of disseminating knowledge on concrete, to promote concrete technology and construction, and to address the research needs of concrete. The ICI was formed in the year 1982 with around 500 members from 5 regional centers. Now we are having more than 14,000 enrolled members from 45 regional centers in all major cities spread across the entire length and breadth of the country. Of these, more than 363 are organizational members. ICI Thiruvananthapuram Center is situated in the southernmost tip of India, having jurisdiction over Kanyakumari, Thiruvananthapuram, Kollam, and Pathanamthitta. Our members include engineers from the academic side, practicing engineers, engineers from the industry, and construction chemical companies. We give out awards yearly in the following categories: outstanding concrete structure in residential, apartment, commercial, infrastructure, etc. Best built house district-wise, outstanding concrete engineer. Outstanding concrete engineer, that is a young engineer. Today's Dr. I think Dr. Nivin Philip, he has bagged this award from Kochi Center. Outstanding student chapter also, we are giving prizes, and we are giving prizes to outstanding thesis in the field of concrete. Regarding high tech, it is one of its kind company in Toronto, providing all kinds of solutions for structural rehabilitation, structural retrofitting. We are with us technically sound supervisors and laborers for doing any type of structural strengthening works. We are also doing foundation strengthening works using nanochemicals, polymers, and cement in proportions solely devised by us for various conditions. I once again congratulate the organizers for arranging this very good topic tonight. Thank you very much.
Thank you, Anwar sir. Now I request Mr. Jitin Kurin Andrews, Consultant Turtle Smart Solutions LLP and Assistant Professor, Department of Civil Engineering, St. Kitts College of Engineering, to formally introduce and invite our guest speaker.
Good evening, all. Today, the duty that is assigned to me is to introduce the speaker of the day, Dr. Nivin Philip. Dr. Nivin Philip is presently working as the professor in Department of Civil Engineering, St. Kitts College of Engineering. He has won the Outstanding Concrete Engineering Award Young, conducted by the Indian Concrete Institute in 2022. He is presently serving as a technical committee member for the Projects in Rebuild Kerala initiative, Government of Kerala. He is a member of prestigious organizations such as RILM, ICI, ACE, and many more. Nivin Philip is recognized as the PhD supervisor in Kerala Technical University. He has more than 30 publications in Index Journal and has done several funded projects as well. On behalf of the organizers, I invite Dr. Nivin Philip for the technical session. Now, before starting the session, let me just add a couple of points. Since we are expecting participants from outside Kerala, the medium of discussions will be in English. Now, if the participants have any questions, they can either post in the chat box or you can discuss that during the panel discussion at the end. Kindly stay muted and we'll have the discussions at the end. Over to Nivin, sir. Thank you.
Thank you, Jitin. Thank you, Jit sir and Anu sir. Hope you can see my screen.
Yes, sir.
Yes.
So, good evening, Stafford. So today I'm trying to discuss what are structural forensic investigation, or what we can do, or how we can do a forensic investigation in a concrete structure. So before going to the topic, I just want to that why we require the forensic or investigation of a concrete structure, that we have to identify the exact solution of a failure that happened or maybe going to happen because of the visible issues in the structures. So forensic means we need an exact technical or scientific solution for the maybe for the exact retrofitting or repairing solution. So here it's some main points comes, it's sustainability. So when we predict or repair or we give some solution, it should be sustainable also. So when we are going to build building bridges or other structure which are going to facilitate failure, which is hindered to judicial proceedings, maybe some legal aspect should be there when a failure happens. So we have to identify what should be the exact reason. Maybe it is level in the design, maybe it's level in the construction, maybe it's in the service condition. So these kind of identification is required. Normally what we are doing, we simply go around and pick the what with the failure crack issues, but we don't go in-depth solution reasons. So that's why the forensic picture come into picture. If you look in the picture that we saw in the side of this, we can see a building which is settled. So this failure of this structure which happened because of the lack of investigation they're doing at the time of foundation. When you are constructing some structure, the foundation is not properly designed. So the failure is due to this happen because of the not proper investigation. That is at the design stage itself, this failure happened. So what we can go wrong, or where we can go wrong? We can go wrong at the planning stage, maybe at the design, that is concept calculation and drafting stage. Construction interface or shop drawing time, it also happens. Erection at the construction time, erection, inspection, and accident also happens. In services condition, maybe overload, maybe the design alteration will happen. At the time of design alteration, maybe we neglect some loading condition or alterations. We didn't redo the design. So these kind of issues will happen. And also at the time of service life, maybe overloading, also the deterioration, because the lack of quality of material will also have an issue in the failure of the structure. So maybe the main reasons of failure maybe happen due to negligence was point, then maybe incompetence, that is the failure to understand the engineering principle or respect to technical limitation. Maybe when we are deploy some engineers at the site, maybe they don't have that much experience to understand what written the drawing or the draft drawing or shop drawing. That will also cause some issues at the time of implementation. Then oversight, some document maybe didn't consider in the safety purpose, that's also issue. Greed, that is normally everyone is working on the profit side. So then disorganization, miscommunication between the engineers from the laborers, then the execution stage. So these will happen. Maybe the reasons of failure will be varied. So we have to identify this reason, so the exact. Then also the construction stage. If inadequate appreciation of loading condition, bad erection, lack of communication between the maybe in the structural part and the construction execution part. So this will have an issue. If you look in the side of the figure, these cracks happen due to the construction, the design. There is this slab crack happen. When the design happens, it is giving a slab, two-way slab with short span and long span. What will have that at the time of implementation, the site engineer doesn't know how to align, maybe the fresh engineer, and his direction of long span and interchange. So what will happen that the structure is go for bending and the correction failure happen. So this kind of error will happen. This is at the implementation, not the design part, at the implementation part, this we see. So this kind of exact reason we are finding, we have to find when we are going for a forensic. So what kind of failures we can expect in a forensic means maybe some structural deficiencies such as overstressing, cracking of excessive deformation, maybe vibrations that are observed. And if you look in the, when a part of structure is failed, 50% of the structure is failed, and maybe sometimes the damage already occurred sometimes before. When face such cases that it is already in the dispute or in the court, which is already happened maybe in the, when I have attended some cases which is already happened in 2010 and I am going to visit in 2019. So already happened 9 years before, and we are going to judge and evaluate that kind of structure. So this will happen when we are going for a forensic structure. You can see the side, it is a old construction which has happened, and this is structure. You can see this is most of the structure where not a structural failure, it is more of deterioration failure. So the quality of the material is comparably, maintenance, we can say maintenance is less. So these kind of many factors will come into picture when you are going for a forensic. So how to avoid this? How to avoid means, how will you evaluate? Maybe we can say, how will you evaluate? We have to evaluate by structural engineering level, that is at the design level, or material quality level, how the quality of material we are using. Then we have to know, when we are making a complicated structure, we should know what should be the behavior, how it behave, that should we have to evaluate. Then based on observations, we can identify any inharmonious material, then defective specification, any settlement, restraint or constraints happen, any severity in secondary stresses acting as a structure made from time to time, maybe any modification or anything happen. The stresses acting on the structure, if any defect already happened and we are modifying the structure, then that failure may be prone to failure, maybe extend the failure. Also, some cases will happen when an accident or something happens, the structure will also fail. That case also we have to identify by the exact reason or how much damage happened in the structure. The left side figure is due to a collision of a vehicle in the building, and it's the total column and the nearby beam is collapsed. So these kind of cases will also come other than the quality or the design issues. So why is the necessity of investigation? Normally, we have required tremendous amount of information is required while we are going for a failure studies. And small inadequacy of performance, any particular element of structure may also have an issue in the failure. The correction. So construction errors and another minor design deficiency get a shelter. So most of the cases that if anything happens, it will go to the workmanship. It is due to the construction. Actually, a lot of cases are there that the design itself have some fault is there. So we are forensic investigation. We are identifying these kind of reasons. So then at the investigation, what should be the outcome and how the technique should be done? So when we are going a forensic investigation, we have to collect information from the technical side that we are already told. Then political issues, anything is happened or inside. Then legal aspect, how the failure happens, what will be the legal procedure, whether it is in court or any dispute committee. Then you have to go through that also. Then serviceability, whether the failure structure it is repairable or it is total demolition is required. So that kind of studies. Then accountability. Accountability means the failure happens, who will be accountable? Who will pay for it? If any insurance is there or if any fault due to an external issues, who will be accountable for this kind of money? Then responsibility. Who will the responsible person to take the remaining? So these accountability and responsibility will be a main part in the forensics investigations. And also, now that we are engineers, we have to give recommendation and solution also. Who should be accountable, who should be responsible, and we have to give the solution for exactly. And also, we need some construction address. Confidentiality should be required. When you are going a forensic, in most of the cases, the forensic investigations, we are going for a legal aspect. So what we are doing should be a confident, then costing, then at the stage which failure occurred, we have to identify. So then also unusual loading, it happens, we have to identify any misuse of the structure, maybe overloading or any alteration happens that not intended to design at the initial stage. Then deterioration of the structure, maybe poor quality of material use or some external chemicals or any other issues which happen. Then special activity damages, then addition, already I told you additional alteration will be there. And also we have to pick on problems, we have to identify the problem, we have to collect data, then how will you going to improve or what recommendation we are giving. So any shortcomings in the design, in construction, material combination, everything we have to monitor. So clearly we have to bring out all the factors that affected the structure and its failure. So that's the main aim of a structural engineering. So why it is different from a conventional means conventional investigation. What we are doing is we are going for an investigation like observation, technical assessment, damage causing source, present safety recommendations we are giving normally. We are not going to the exact rules, solutions because we have to certain level of investigation, we need additional equipments for proper investigations. So in early days, we are only doing by visual exploration or some small entity tests like a rebound like that. So we have to give some exact solution, how to rectify or how to give a solution. So these are the conventional issues when we are going for a check-in, like we have checked in the external facade, any peeling of plaster should be there, then efflorescence, splint protection, any water presence, groundwater flooding is there, then any plumbing issues, when building has any projections, additional projections or construction happen, then terrace inspection, then housekeeping is for any water is flooded or it is not properly drainage is given. So these kind of things we normally inspect when we are going for a normal investigation. So why forensic is important means we have new day exact technical specification, it what solution at what location exactly should be given. So that's the main forensic investigation come into picture. So forensics means investigation everything from collapse to crack in a diverse range. That means we have to identify the reason from the design level to the collapse level. So it may be caused due to some seismic, flood, maybe corrosion, fire, etc. So we have to identify the exact reason. That is, so exactly forensic investigation means we are gathering necessary information that the cause of failure in the application of engineering to define as an instance when structure does not conform the design expectation. When it is not design, failure is also not a maybe insufficient design. If the structure is not properly designed, so that is also a failure condition. Collapse is not always necessary when you say a structure is failure. So what we can done in a structural forensic investigation? First, we have to identify the damage assessment. So we have to give an exact reasonable clarity the causes of damage that measure in the extent of structure. Also decide to appropriate corrective measure. So how will you quantify it? How will you going to rectify it? That's the main part. So in structural forensic investigation, we can do in two ways. Normally, we already know destructive testing and also non-destructive testing. In destructive testing, some of the examples are given. We are taking the core sample for compressive strength. This is the core sample which I show in the last slide. That is a cylindrical core we cut from the site for testing the compressive strength. That is then for RCPT, rapid chloride penetration test, for checking the permeability or porous nature. For that, we are taking samples around 100 mm by 50 mm depth, 100 mm dia by 50 mm depth. From that, we will identify the porous nature. Then we drilled samples. We will take samples from the site of the structure to identify the presence of any chlorine or sulfate in the materials, or whether the structure is exposed to the kind of chemicals for identifying the deterioration. Then steel sampling. The steel structure is used. So we have to take the sample from the structure first. Then pull out test to identify the quality of the concrete. Then some chemical textures. We already know when we are taking some samples, we can go for some scanning electron microscope or XRD SEM analysis. We can identify the presence of this chloride, sulfate, everything, and any maybe from alkali aggregation. We can technically do with this kind of tests. So why NDT is important? Sometimes certain structures maybe that can be failure doesn't happen from the outside. So we can, NDT is a good solution. Other than destructing certain reinforced structure, maybe highly reinforced concrete structure, core sampling is not a good solution because we are cutting the reinforcement. Sometimes it will happen. So in order to avoid that, we can go for non-destructive testing. In non-destructive testing, we are measuring the different kind of properties like compressive, flexure, and tensile. So these are the some of the technique we are using for non-destructive testing, like rebound hammer, which already most of the engineers know what is rebound hammer. We are measuring the compressive strength. Then UPV, then rebar locator to identify the exact location of the rebar, whether it is given as per the specification given in the structural drawing, or when we are taking any corrosion test, we have to locate the reinforcement. Then half cell potential to identify or corrosion rate. You have to identify the how much corrosion happened to the steel. Then pull-off test to identify the cover. Go into deep that. So rebound hammer, most of them know. We are measuring the rebound number from the concrete surface. Only one thing, I didn't go for the theory. One thing you should know that when you're going for a rebound test, we should, if 1 point is concerned, we should take average of 9 points. The surface should be smoothened, then only go for the rebound hammer test. So based on the position, how we are holding the hammer, we will get the result based on this curve. So only thing, when you are checking 1 point only, you have to take at least 9 points, like a grid you have to form. Otherwise, some anyway, the accuracy is only 15 to 20% variation will be there with the composition of the cube. So we normally will take the average value. So why we are taking it's an average value? Because the smoothness of the surface, geometric properties, age of concrete, and surface and internal moisture condition also will influence the rebound value. That's why we are trying to averaging the rebound value number of a particular point. And another is penetration resistance method. Penetration resistance method, we are punching a needle to the concrete, and based on the punching depth, we are identifying the strength of the concrete. Nowadays, we are not using. In most of the maybe some technical side, it will be there, but we are not recommending, because if structure is not damaged, it will create internal cracks on the nearby surface. When we are hammering or we are giving a punching through a hammering action, this will create internal other cracks, which will later stage will cause some issues in the concrete. So anyway, this test is there, but we can, based on the penetration depth, we can identify the quality of the concrete. And these are the codes which substitute these test methods. Another method, and this also influenced by operating error will be there. Size of the aggregate will also matter, and the nature of the concrete. This everything value will be NDT will be influenced by, mainly influenced by the one of the main point you have to note, size of the aggregate have a very much influence in the strength. And pull-out resistance. In pull-out resistance, one of the disadvantages is that we have to place this. You can see a head portion and a shaft portion is there. This head portion should be already installed at the time of casting it, or it should be fixed in place. Then only we can test work. So if you are going to monitor a infrastructure project like that, we have to already install at the time of construction itself. Then only we can monitor how much load it can take. So what we are doing is we are ensuring a shaft, and this shaft should be trying to pull out from the concrete. So from pull out, how much resistance it is giving, we are measuring. Based on that, we are predicting the strength of the concrete. So it is mentioned based on the ASTM standards we are using. Here also, the main influencing factor is aggregate size and the cement mortar, and how much depth we are inserted this head portion. How much depth we are inserted, it also affect the resistance value. Next is pull-off resistance. This is very much important nowadays also, in which what we are doing is, it is a method to determine the quality of cover concrete. Cover concrete means the reinforcement cover concrete. We are checking the bonding efficiency of the cover portion to the reinforcements. If it is concrete is reinforcement is corroded, then also the bonding of between the cover concrete or the outer layer concrete doesn't have any contact between the reinforcement, then it will be easily pulled out. So that test we are using this pull-off test, in which what we are doing is, we have a test disc is there, or 50 mm dia. We are attaching that disc to the concrete surface with some epoxy resin or many acrylic we can with that. Before that, when you are going, before pasting it, we have to clean the surface properly. Maybe with some acetylene solution, we have to clean the surface properly. Then we will do the gluing with the epoxy and wait for 24 hours, depending on the epoxy setting time. Then what we are doing is, we trying to pull out this disc from the surface. One thing you should remember, that when we are after fixing this disc, we have to isolate this portion by making a circular cut, or you can make a 50 mm cut circular diagonally up to the reinforcement layer. Then you have to place the disc. Otherwise, what will happen, that when we are trying to pull out, the nearby cover concrete also have some influence in the bonding. It also shows some effect in the bonding cover strength. So we have to isolate the gluey portion with the remaining concrete. That's why we can see a cut is made in this area. Then we are trying to pull out, and the crack will happen, and we will find out how much strength bonding strength will be there. When you're designing, we will see some TOBD value, bond strength value will be there. That kind of shear, that is based on the shear stress of the concrete. That shear stress value we will get it from the test. And these have some limitation is that we need 24 hours for setting that adhesive. And also this factor also influenced by the size and type of cold aggregate, because we are using a 50 mm dia, so 20 mm cold aggregate is have some limit. Otherwise, we have to increase the size of the disc. Next is permeation test method. Permeation test is a vast area. We can see the permeability test on concrete. We are identifying the porous nature. When we are going for some chemical pipelines or any structure, marine structure which is subject to sulfate or any chlorine solution, we have to check whether it have a durable or it have less porous. So that kind of time we will go for this permeation test methods. That hydraulic permeability is there, gas permeability is there. Then already I told you RCPT, that is chloride ion permeability. We will identify this method with this permeation test method. In gas permeability, we are making a suction of air from the portion which you are concentrated. So if you look in the side figure, we can see the section is considered from the central core portion of it. There is a two portion is there. Outer. The outer section is given to avoid the influence of the surrounding airflow. To avoid the surrounding airflow, we have an external suction area is there. From the internal portion only, this direct, we can say F4. That direct flow we have to measure, and based on that, we are checking the permeability of the through gas permeability. Through air, we are identifying the porous nature of the concrete. Normally, it is done for the cover concrete or all the slabs also. Then from the permeability, we are getting a measurement called permeability coefficient. Based on this coefficient value, we are quantifying whether it is a good, bad, like that. This classification is based on the K value. It doesn't quantify the any strength or something like that. It's mostly based on the quality of the concrete. Some relations are mentioned, but mostly it is only just a representation of the quality. Next, another is chloride penetration method. So in this case, we are collecting when a structure is deteriorated happen, we will take samples of 50 mm dia by 100 mm dia by 50 mm. So then we go for a rapid chloride penetration test. What we are doing is one side is filled with the sodium hydroxide, another side is filled with the sodium chloride. We will give some electric volt and try to transfer this chlorine ion from one side to the NaOH, the other side. And how much percentage of chloride ion is transferred? We monitored around 6 hours. From that value, we will identify how much permeability is. So normally everyone will know it is how the based on this ratio, maybe the summation, some equation is there. Based on the summation value around the 6 hour duration, around 30-minute interval, we are taking that reading. Up to 6 hours, we finalize the value. Based on that, we are calculating the charge pass, how much and charge pass. Based on that, we will whether the chloride is whether the sample we are taken is good or bad. High permeability means it have highly porous. So when we are going for a normal concrete like M25 and 30, if it is a normally good concrete, the range is normal it should be between 1000 to 2000, or it should be 2000. The range should be in less than 3000. But if we are going for a high strength or high performance concrete, which we are using any fly ash or admixture like that, we will normally get a value less than 1000, because when you are using this kind of admixture, we will get a lower value. So when we are identifying our forensic investigation, what the use of this is that when a deterioration happens, the porous nature or it will increase, or the deterioration or the quality of the concrete will be lesser. At that case, we have to identify whether the is corroded due to the poor quality of the concrete. From this test, we can identify the porous nature of the concrete. And another is ultrasonic pulse velocity. It is another technique used to measure the damage of uniformity of concrete, the damage, interior damage, any honeycomb is there, delamination is there. So UPV is the initial technique that developed. Now the most modern technique we call ultrasonic pulse echo. is little bit modified from the UPV test. The ultrasonic pulse echo, what we are doing is we can measure it from the same side. It isn't required one should be connected on the face, another should be on the side face, or it should be on the back side. From the same face itself, we can identify the echo of the pulse generating. From that, we can identify any issues in the structure. So this is the modified form of ultrasonic pulse velocity. That is ultrasonic pulse echo, we can call it. And these are the standards. Now ultrasonic pulse echo, the equipment is available now, only available in the market is PD 80,000. That is for the POSIC, it is given. And these are the standards for this kind of test. And one of the main in all the cases is corrosion. So whatever reason, any moisture or presence of any chlorine, the corrosion will happen. So corrosion means it can be tested in different ways, because what will corrosion happen, that it will form iron oxide. And one of the main advantages, iron oxide is chemical, electrically, and magnetically conductive. So that is the easiness we can identify the issues in the rebar very easily. So one of the two methods in the corrosion are, first is half cell potential, most of them are using. And another is corrosion resistance, or we can call it as corrosion rate, is a separate technology. It's another technology nowadays developed. So in half cell potential, what is doing is we are making a half cell with the copper and copper sulfate solution. And this is, if you look, this is a concrete structure in which the anode it is showing like a rebar is going, and this half cell is placed on the surface of the concrete, and which is connected to a voltmeter in the negative, and another wire is connected to the reinforcer. So one of the main point that when we are going for measuring the corrosion resistance, we need a connection to the reinforcer. So what is the main difficulty in this corrosion resistance method? We have to explain a connection between the reinforcement and the result. And this test is highly influenced by the moisture content. That is, the surface should be properly, moisture should be there, and it should be equal moisture. The moisture should not be different. The water, the moisture content should be equal in all the area. Otherwise, this test should be influenced by certain amount. And also the current will flow through this half cell, and it's go to the rebar, and then it is connected to the voltmeter. This is the way we are making a half cell. And one of the disadvantage I am saying is that half cell will give the value, but in two stage only. Whether our rebar have a 90% corrosion or 90% is good. No corrosion happen. That is, the voltmeter will have a millimeter minus 350 MV. It should 90% probability of active corrosion is there. If it is less than minus 200, then 90 probability of no corrosion is there. So in between, we cannot identify how much corrosion is happened, whether we can retain that reinforcement, that is not there actually. So it's a gap in between this, either 90% good or 90% bad it should be there. So there is an uncertainty in this value. If it is get between minus 350 to minus 200, we don't have any solution in the half cell potential. So that's why we can say that half cell potential is not that much predictable when you are going for a forensic investigation or exact solution we are giving. It is not that much useful, because sometimes we cannot replacing a reinforcement or part is not required. Maybe we can rectify with some amount of maybe properly covering the concrete with new amount cover concrete. That is maybe sufficient for further reduction of the deterioration. In that case, this CIPRA technology, or CIPRA technology, the connectionless electrical pulse response technologies come into picture. In this, what we are doing is we are measuring the electrical conductivity of the rebar by inducing a high voltage frequency. High voltage frequency we are introducing to the reinforcement with some electrodes. It doesn't require any connection to the reinforcement. So what will the principle is that at lower frequency, the corroding rebar will show a high voltage, but a non-corroding rebar doesn't have any influence in any change in the voltage. Corroding rebar at lower frequency will have a high voltage will show. So from that technical point of view, we can identify whether the rebar is corroded or not. And these are the most modern technique nowadays it is using for finding the corrosion. In this case, it is very helpful for identifying the exact reasons of the corrosion happening in the structure. Now I'll move on to one of the case study which I done in the 2022. We are investigating a forensic of the stability assessment of a seminary building, which is vastly constructed in 67 or 70s in early days. So what we are doing is, first, normally in what we are doing for a forensic analysis is the same thing, conventional, like we are going for a visual inspection. So visual inspection, we are identify what type of crack should be there. We are collecting samples of the materials. We are identifying the location of deteriorations. Wherever the crack, we have to mark it, and we have to identify how much crack is propagated, to what extent, whether it is extending to the foundation, and what will happen to the any delamination or spalling is happen. So we have to identify everything by visual inspection. And if any moisture presence will be there, any corrosion specific spalling happen, we have to identify and mark each endpoint. So you can see if the right side is a crack which is propagated from the foundation level to up the roof slab level. It is going on increasing. So this is the main cause. If you look like that, we can identify that the issue happens from the foundation level itself. So this kind of thing we have to identify before going any NDT or core sampling. Then what we have done is that we have went for a to measure the quality of the concrete at that building, and we are find out around 100 points around like that. We are identify the compressive strength at each point, and we are monitored that most of the areas where compressive strength is less than 10 Newton per square. So it is the concrete is getting deteriorated due to some chloride or sulfate issues. It is getting lower than 20. So it is not now the concrete strength value is lesser compared to how much it is required for an RCC. Another test we conducted is pull-off test. Pull-off test, which already I told you, we are measuring the bonding of the cover concrete with the reinforcement. In that, normally the failure will happen in when you are measuring a debonding. It will comes in 0.41 to 3.41. 0.4 means when it's normally for a compressive strength, the bonding stress will be normally given for M20 to M40. It should be come in this range, 0.41 to 3.41. But in our most of the cases, these values is much lesser below 0.41. So only 3 point I got, it is around in between 0.41 and 3.1. Rest of the point is lesser than 0.4. That is lesser than 0.41 means already the rebar is corroded. There is no bonding between the reinforcement and the cover concrete. So we can conclude based on that. If you look in the 3.38 and 1.38, we can say that some concrete have the quality of M30 and somehow lesser than maybe M20 or lesser. That is 1.3 is coming, maybe it is coming around M15 range only. So this kind of thing we can identify from the bond strength value. So another test we already conducted at that, we have to measuring the corrosion. If you look in this picture, we can say wonderful slab, which doesn't show any spalling, any corrosion is there, and is properly painted and everything. And we are conducting corrosion test at that point using that new technology. So we can see before going to that, we should do one that the concrete surface should be properly to the equipment. Any painting or anything should not be, you have to remove that before going the test, because in between layer, we cannot identify the exact percentage of corrosion. So what we have done is we just grid this form. So in corrosion resistance, we are doing mapping a whole area, maybe a contour. How much area we can also contour? Maybe a 10, 20 or 30 meter, we can make a contour, no issues. At least 4 points should be required to make a contour. So we made a grid of 9 by 9 and we removed the cover concrete, cover plastering paint and cover portion. Then we tested at that point. both in the x direction and y direction. The x direction and direction means both in the slab, long span reinforcement and the side short span reinforcement. And we obtained a value which is called corrosion rate. Corrosion rate is different from corrosion potential. In corrosion rate, we get a wonderful contour. You can see a contour, which if it is green, the value is from 0 to 43 something mu ampere per centimeter square. If it is green, we can say this is no corrosion. If it is red, it is highly corroded. But in between, you can say 1.7, the reinforcement have a yellowish tint. From that, we identify that the reinforcement is not fully corroded. So if it is properly maintained, we can use this reinforcement. Further, chances are there we have to repair it. But when you're going for a half cell potential, what the issue does, corrosion is happen. Either we have to remove the concrete or no corrosion happen. So in this case, we can identify how much percentage of corrosion happen in this. This is the y-axis. This is x-axis. Only difference is one measuring the long span reinforcement, one measuring in the short span reinforcement. And this is the concrete resistivity. Simultaneously, the same equipment we are using can measure the concrete resistivity also. Concrete resistivity means whether the cover concrete have the quality to resist the corrosion. That measuring in the concrete resistivity. So if you look this picture, the corrosion happen. If you look in the next picture, you see it is a highly reddish color. So this means the concrete is too much porous. If any moisture or chlorine presence is there, it will be susceptible to corrosion. So maybe this porous nature will be the reasons of the corrosion. Sometimes, if properly painted, then there won't be there. But the concrete, cover concrete quality is much lesser in this case. So either we have to identify the remove the cover concrete, or you have to avoid the further penetration of moisture or chemical to the reinforcement. That we have to do, because the quality of the concrete is very less by doing this test. And this is another slab portion which can have similar result. We can see the corrosion rate of y-axis is good, and somehow corrosion is happening. But if you look in the corrosion concrete resistivity, we can see the 50% portion of that area is a greenish tint will be there. That is, the value is 295 only. That is the greenish portion. This come range only, and only certain portions is have a dark reddish color. That means this have a highly porous in nature. So by doing this concrete resistivity test, we can identify where the concrete quality is low. At that point only, we have to rectify it. So we can rectify the required portion only by identifying this contour. Remaining portion, maybe we can, it is a slight greenish color, maybe we can avoid any repairing work, or we can doing any painting or anything. Simple solution is sufficient for further propagation of the moisture. This is for a floor slab. Next, another case study. This is done, not done by me. The company gave me a case study of what they had done there. So in this, what they have done is they are measured the corrosion of a whole bridge at the deck portion and the abutment and pier portion. They scan all the bridge. One of the main advantage of this equipment that we doesn't require any connection, which I already told you, to the reinforcement. Also, 5 to 15 seconds is sufficient for taking 1 point. So for evaluating the whole bridge, we won't take that much time like the half cell potential. So it is very easy and comparably simple. In this, they are monitored around the abutment quality by using this scanning machine. From that, they get a value. If you look into the value which got from this new machine, it is called ICOR. They are patented like that. The corrosion resistivity value. And they are compared with the half cell potential and electrical resistivity. Electrical resistivity is an old method of identifying the corrosion by evaluating the concrete quality, whether corrosion happen or not, something like that. If you look the three methods, we can see the ICOR have an exactly solution of where it is corroded or how much percentage is corroded, less corroded area, and some greenish portion also there. It is good area where is no corroded happened. But if you look in the half cell potential, we can see that The lot of area, there is a yellowish tint is there. The yellowish tint is the blackout area for half cell potential. That is minus 200 to minus 350. We cannot predict whether there is a corrosion happen or how much percentage of corrosion happen is not given. Or above 350 or below 200, we have the solution for half cell potential. In that case, the ICOR have a very much good solution for analyzing the deterioration or quality of the reinforcement. Similarly, for the deck portion also, we can see a similar kind of graph, what they obtained. You can see the values is there, and we can see the small area, isolated area. If you look in the X and Y axis, this is the whole length they are measured. Length 0 to 12 meter, height 3 meters. So this whole deck area, they are evaluated based on this and identify the exact portion where corrosion happened. Based on that, we can rectify. If you look at the half cell potential, main issue is that the most of the area is yellowish region. We cannot identify the exact portion what we have to do in the yellowish region. Whether we should repair the tower concrete, whether we should do any other test, so something like that. In electrical resistivity nowadays, most of them not using because it doesn't give any exact solution to anywhere. So because it's most of the area they show a greenish color, it is good, but most of the cases it's not happening. So electrical resistivity nowadays is not using, only half cell potential and ICOR is using. So in which ICOR has a better positive side is there. One of the main advantage is that when you are using this equipment, we identify the corrosion happen. Simultaneously, after if you remove the concrete portion and repair it, and with new concrete or anything cover, then also we can test after 28 days whether that repaired area is good or not. If the repaired area give a positive greenish color, then that is sufficient for repairing wall. So again, the concrete wall is good. The structure can be, we can repair it safely. We can evaluate our performance in the later stage. Simultaneously, if you give a yellowish color in the in this contour map, we can also predict how much year the remaining reinforcement will last, or how much deterioration or corrosion will happen after 10 days. From that value, we can somehow predict the life of the corroded rebar if no repairing is done. Otherwise, we can identify and repair it very possibly. So when we are doing a forensic analysis, we have to go for in-depth deterioration analysis. This is the one part only, 30%. Remaining, we have to do all the political accountability, reasonability issues we have to identify, and we have to give the exact solution. In early days, we don't give exact solution. We cannot quantify it. So forensic means we have to quantify everything and give an exact solution for the forensic study. That most of the cases, the forensic study comes from the court or any legal issues. So at that case, this kind of quantifying is very necessary. So that's also from the case study, and that's all. Thank you. If anything you have to ask.
Thank you, sir. That was a wonderful presentation from Nivin, sir. Now we can start the panel discussion. So I invite the moderator of the discussion, Engineer Ajit Kumar GS, an eminent practicing engineer who has more than 30 years of experience in the construction field and tech positions like Project Director, Project Management Unit, Tribal Kerala Initiative LSJD, Superintending Engineer PMGSY, Superintending Engineer Thiruvananthapuram Corporation, and now he is a freelance engineer consultant. Now over to you, sir.
Thank you. Thank you. Thank you, Nivin sir, for a wonderful presentation.
Thank you, sir.
We have expert panel of four members. That one is Shri Anwar Hussain sir. He's an eminent engineer and former deputy chief engineer of local self-government department. Currently, Anwar sir is the director of high-tech total solution provider and chairman of the Indian Concrete Institute, Thiruvananthapuram Center. He is an eminent rehabilitation specialist in Kerala, especially who started the rehabilitation work in the early 2012. And I welcome, sir. Next, second person, Dr. Mini Soman, ma'am, former professor and head of the department, College of Engineering, Trivandrum. Madam is well-known structural engineer and an eminent academician. Mini ma'am have very good exposure in both academic and industrial concerns. Now, Mini Soman ma'am is the secretary of the ICA's Thiruvananthapuram Center. I welcome, madam.
Thank you. Thank you, sir.
Then we have an eminent engineer, Biju sir. Biju sir is assistant professor of Department of Civil Engineering, College of Engineering, Trivandrum. Presently, Biju sir is the well-known structural engineer. Biju sir.
Thank you, sir.
Biju sir currently is a consultant of various government organizations. Also having, Biju sir also having both academic and industrial expertise. Welcome, sir.
Thank you,
Then,
sir.
Engineer Shankar. He is the assistant director of Kerala Highway Research Institute. He is young and enthusiastic, having immense of experience and exposure in structural forensics. I hope all of you will share your experience and specific issues you met in your professional life with other engineers. I welcome Anwar sir to deliver the speech.
Thank you, Ajit. Thank you, Ajit. First of all, I want to congratulate Dr. Nivin Philip for this unique and wonderful session on forensic investigation of concrete. You have gone in depth to deliver your lecture. I am particularly happy that I have been trying my level best to put into practice the science for the past 11 years. I was and is using as much course, testing equipment, and interaction with the besties in this field before putting hand on any retrofitting or structural rehabilitation works. I had to handle a lot of half-done buildings to complete them, somewhere up to lintel level only. That is masonry structures. For this, I took samples of bricks from the brick masonry, tested in the lab, done stress analysis of the whole building. It may take more than 1 week to complete that stress analysis. And then compared with IS 1905 and gave clean sheet to construct 2 floors. In another case, while doing the stress analysis of building, I found that a single-story load-bearing building, which I checked, will not take further floor. So we resisted from further vertical extension. In my order with laterite bricks, and when I did a forensic investigation with a 2-story building, I was taken aback to see that the actual stress of the brick masonry was far above the allowable stress as laid down in IS 1905. The latter stone, when checked, has less than 2 Newton per mm square as its strength. So Biju sir is here. I and Biju sir both are in the technical committee of Mangalam Temple, and we faced the same situation there. The strength of the laterite bricks we took from the temple, and after checking it, we found that it is around 1.5 Newton per mm square only. In another, there is an individual brick, not brick masonry. In another 3 cases, I had to jacket brick pillars in the ground floor to construct another floor. All these were done after proper stress analysis. Then the various RCC members have taken a lot of time for us for assessing the strength and corrosion of bars. In one case, a new beam had to be constructed to support the existing slab to avoid deflection. In that case, we provide negative reinforcement on top of the beam also for the slab. Investigation on RCC columns are interesting, particularly when the water table is above the foundation level. In that case, it will be very difficult to rectify or or strengthen that column at least for some time, because we have to ensure that there will be no corrosion after cathodic treatment or nowadays another material has come to market. It is some sort of capsule and it is embedded in the concrete, and the vapors from this capsule, these capsules are placed 2 meters center to center. The vapors from this capsule enter through the pores in the concrete and reach the reinforcement, and this subsequently give passivation layer to the reinforcement. Anyway, I have not checked it, but I'm in the process of doing one test regarding that also. And Dr. Nivin Philip has talked a lot about the concrete also, about porosity also. Then porosity in Kerala, most people tend to use only M20 concrete, but and this is so even in PWD, which is the largest engineering department, or which is the parent engineering department in Kerala. And now I wish to congratulate the chief engineer of PWD recently. I think it is in March. She issued a circular that every engineer should adhere to table 3 and 5 of ISO 56/2000. That is a positive sign from the Public Works Department of Kerala. I once again congratulate Dr. Nivin for this wonderful session. And actually, I wish to have some talks in future with you. So thank you.
Thank you, sir. Thank you. Thank you, sir. Thank you, sir. Dr. Mini Suman, madam, please share your experience.
So first of all, let me congratulate Dr. Nivin Philip for that speech. And regarding this forensic engineering, I would like to say that it is just like can be divided into 3. First of all, the analysis of the symptoms. What is the distress that is seen outside? Then comes the diagnosis. What is the diagnosis part? What is the reason for that distress? And then comes the solution. That is the actual rehabilitation process. So I find that just like a human being, if you are getting a fever, there can be a number of reasons. So the first thing is to diagnose, and then comes this solution. Solution part is more or less easy. That is what I feel. But the diagnosis part, what is the problem? What made that problem? What is the cause of the problem? So, and with the help of the non-destructive testing, that has become that was a great powerful tool towards this forensic engineering. As the sir has already explained the different methodologies and all. So that has made this forensic engineering very popular. And we have also that has made concrete no more transparent. It is not no more opaque. I mean to say opaque. It is a transparent thing. Now we can find out what earlier it was not the case. Once it is placed, that is over. We did not know whether it is as per the design or not. But and also what is the concrete, the grade of concrete that is placed. That was difficult to know that. Only from the symptoms we could see. But that is not the case. Now with NDT, we can very easily find out what has happened on the site. And depending upon the problem and the diagnosis, we can find the solutions. I do had some occasions to do this with certain, that was one with the CIMIST, that is Pujapura. And this happens mostly. This forensic engineering is required, as already explained. This may lead to sometimes litigations. The problem is we do not know. Once the concrete is placed, we have to wait for the 7th day results to see whether the right concrete was placed. So that was and once it is known that it is not the required one. For example, for a column, if M40 is designed and if you're providing M20, After 7 days only, we could know this has happened. That is the problem. So now the only solution is either to demolish or to go for this rehabilitation. So that is the significance of rehabilitation, and especially massive structures. When and another cases when after maybe 10-story building, after 7-story, there may be some litigations, and it has to remain as it is. So it may remain for so years, and after so many years, we may not be knowing whether to continue with the construction, what is the present situation. So there comes the relevance of this forensic engineering. Anyway, all the aspects of this was dealt by Dr. Nivin Philip. So once again, congratulations. Thank you.
Thank you, ma'am. Did you, sir, please share your experience?
Okay. Good evening, one and all. So a nice presentation by Dr. Nivin Philip. Unfortunately, I'm currently sitting in my car and in a driving seat. Okay, leave that for the time being. Now, he has given a very good talk on forensic engineering. As Anwar sir has conveyed, myself and Dr. Mitra DC is also being a participant of this particular program. Myself and Dr. Mitra DC, along with the help of LSGD, especially Anwar Hussain sir, we have been we have been checking those structures which has got some problems from from the 2010 onwards. So for the participants, my advice is always you can go for this sort of forensic engineering with proper knowledge. So in order to obtain or in order to have better knowledge of this sort of forensic engineering, I will recommend some codal provisions also that you have to read. So that will be one will be SP23, causes of cracks. Okay, so there is a special publication 23 by Bureau of Indian Standards. Maybe the participants, I have seen that the participants are some are students, some are faculties, some are engineers from the reputed firms, and some are engineers from the government agencies also. So they can have a look at the SP23 code. Then the other one they have to refer is there is a CPW manual is there. Repair and rehabilitation of concrete is there, or concrete building is there. You can refer, it is a very, very, very good manual. Okay, CPW repair and maintenance manual. How we have to assess a building, what are the various tests to be conducted on a building as part of forensic engineering, that it is noted in that particular manual. And after doing the proper forensic engineering, we have to properly retrofit the building. So retrofitting the building is also one of the main important criteria that we have to look into it. So again, Indian codes are nowadays stipulating some recommendations onto it. I think there is there are two IS codes are there. One is especially for a masonry building structures, and another one is especially for repairing and retrofitting or strengthening of reinforced concrete structures. So those two codes are right there, and along with those codes, you can refer the leaflets or recommendations given by the chemical agencies or something like that, especially Sarah, Fosroc, Sika, and all those famous companies or reputed companies. Okay. Now, those who are willing to do those sort of works, forensic engineering works, should refer always SP23, then CPW maintenance manual, as well as the various IS codes, along with these reputed journals. Now, Dr. Nivin, let me ask you one question. Maybe I am not interrogating you. Okay. What sort of testing methods have you gone for? Pile or pile cap? Have you gone for anything like that?
Personally, I didn't do so until now. Maybe pile integrity test is there available, but I don't have any personal experience with that. But inside motor side, I didn't get that exposure.
Now, let me ask you one more question. How much that particular electrical resistivity machine cost? The
that final the CPR technology which I mentioned, ICO, that
Yes,
is cost
yes.
Indian cost is around 23 lakhs, sir.
Okay. So there lies a problem with this part of forensic engineering. Many LSDD engineers or many government institutions are facing these sort of problems, maybe due to lack of fund. Okay, it is a must that forensic engineering should be a very good part of the structural engineering side. And but when I request all the institutions to purchase these sort of equipments and should have a very good understanding of these sort of things. Then one more thing that the forensic engineer should look into fact that he should have some analysis also should be taken into mind. Okay. So there should be some analysis either done by any softwares, whether it will be good or not. Okay. So that part also should be covered by a forensic engineer along with the physical observation and also with the mechanical instrumentation side. Now, I do believe that St. Kitts have got these sort of equipments and they are in a right movement towards this sort of forensic engineering. So let us hope the best that they will be coming with a very nice solutions to Kerala government also. So anyway, nice presentation, Dr. Nivin, and nice to talk with you also. So we will keep in touch with you.
Okay, sir. Thank you.
Thank you, sir.
Thank you, Vijay sir. Shankar, please share your experience.
Am I audible?
Yeah.
Hello? Yeah.
Yeah.
Okay. So good evening, all of you. So it was a nice presentation. So I will share my experience with non-destructive testing and forensic investigation of structures. So I am representing the Kerala Highway Research Institute, which is the research and training testing center of Kerala PWD. And we have been into the non-destructive testing of various structures, bridges, buildings, and I am actually associated with a few of the projects. So before I give my experience in that, so I just want to, say my words in align with what Biju sir has said. Before we start doing all sort of these forensic investigation, we should definitely have a very good knowledge in understanding the results, and we should go through these standards. And there is a standard textbook by Bunge, which is a text on non-destructive testing. So all of you can read that textbook. It is a very nice textbook. All the test methods are clearly mentioned, because basically the problem with this non-destructive testing is that we are actually inferring some sort of statistical data from the structure. We are taking some data from the structure and we are cross-processing those data and we are getting some inference. So when it is compared with the normal destructive testing, which has been conducted like cube compressive strength and those tests, we are getting the destructive testing and we are getting a reliable value which is directly correlated to the compressive strength or those kind of values which are used by the structural engineers. But when compared to the non-destructive testing, say rebound hammer will give you a surface hardness value. That surface hardness value you are correlating with the compressive strength. So how good that surface hardness value is correlated with the compressive strength, everything will depend on what correlation you are using. So generally, when we are doing the testing at the site, we judiciously take non-destructive and some partially destructive tests so that we will be able to make some correlation between the rebound hammer test or the ultrasonic pulse velocity or what are the non-destructive tests we do with the partially destructive tests like cutting the core sampling and testing the compressive strength and correlating those compressive strength with the rebound value rather than using the rebound correlation chart which has been given by a manufacturer, which cannot be universally applied to everywhere. And apart from that, for the compressive strength, but at sometimes, as sir has already told, cutting the core will be difficult from the structure because, you have to pay some price. So in that case, you can think of, some sort of other test which is more reliable compared to the rebound hammer, like, you can go for a capo test, cut and pull out test. So that test is, that test is slightly costly. These equipments are slightly costly, but, if you can buy some equipments like, cut and pull out test equipment, you will be able to better give an estimate of compressive strength, which is better when compared to the rebound hammer or other tests which are normally used. So at Kerala Highway Research Institute, we have all these equipments like rebound hammer, UPV, capo. Then compared to corrosion testing, we do all sort of chemical testing. And apart from that, hello. Yeah, okay. So apart from that, am I audible?
Yes, yes, yes.
Yeah.
Yes,
So,
sir.
yeah, yes, yes. So apart from that, when it comes to the durability and corrosion testing, either the problem is due to the chloride ingress or it may be due to carbonation. This is the mostly, this will be the factor which will be leading the deterioration in concrete. So for testing of these chlorides, you can go for some sort of extracting the core samples and you can do the chloride analysis. Like in a chemical test and all. Carbonation also you can do some sort of phenolphthalein and you can check the carbonation. But when you do some sort of non-destructive testing, like what sir has told, mapping the corrosion current, surface resistivity, you will be entirely depending upon the equipment, which is costly, like 23 lakhs, 25 lakhs you have to pay, and you are mostly relying on the data which is given by the manufacturer. Because right now we have purchased one equipment which is called a Galva Pulse equipment, which is manufactured by a company called German. So that they will give us half cell potential in terms of silver chloride electrode, and also we will get corrosion current. But the problem is we have to depend on what the manufacturer is giving, and we really don't know, because we really do not have any other method of even calibrating the equipment. If you have a compression testing machine, you can directly calibrate the equipment with a proving ring. But the problem with these sort of equipment is that you do not have a calibration. I mean, the calibration which will be given by the manufacturer, but you have to rely upon the manufacturer, and whatever value you are getting from that instrument, you just have to rely on that equipment. So these are the limitations with the non-destructive testing. But as Biju sir has rightly pointed out, so if you have a very good understanding and knowledge about the equipment you are using, the test method you are following, how much sample should be conducted, and even minimum was saying, how to do the testing, how to do the sampling, everything. If you are very clear in doing that, you will be able to get a better assessment of the structural capacity of the structure using the non-destructive testing. At the same time, if you are not able to use the instrument properly, or you are not having that hold on the device that you are using, you may ended up giving a wrong interpretation of the structural capacity. And I just add a point on Anwar sir. He was asking about some cathodic protection. Sir, actually, if it is regarding cathodic protection, cathodic protection is basically a zinc anode which is embedded in the concrete, and zinc anode will be connected to the rebars, and this zinc anode will it will corrode because the corrosion potential is high with respect to the steel. So the zinc anode will corrode and it will passivate the steel. That is a technology. I think that answers your question. So apart from that, the presentation has covered everything, starting from the visual inspection, then the method of testing, and how to interpret the results. And it was a wonderful presentation. Thank you, Nivin sir. Thank you all of you.
Thanks, sir.
Excuse me, one more thing I would like to convey to the participants also. So being an academician, I would like to convey this. Okay. So as you know that the codes of Bureau of Indian Standards have been revising each and every year. So the participants who has attended this course should have a look into the various codes of how to test or how to use these equipments. Especially there is a code known as IS 516. IS 516, there is a part 12 versions are there. And as Nivin has shown, 2 slides regarding rebound hammer and ultrasonics test. So as well as core test also. So the previous IS codes for the core, NDTs, rebound and ultrasonic have been superseded by the IS 516. Okay. So all of you should refer the new IS codes pertaining to these sort of tests. Do not refer the old one. Okay. So that is one item that I want to convey to the participants. So anyway, thank you. Yes, over to the panel, sir.
Okay, thank you, sir. I hope Mitra sir is present in this group. Dr.
Yes,
Mitra
yes.
sir, please convey your message and experience, sir.
Thank you, Anil. First of all, I would like to say that Nivin sir has delivered a wonderful talk regarding this forensic engineering. And already Biju is my colleague. He has already mentioned that both Biju as well as Bindu Kia teacher, we were a team working to investigate various problems associated with LSTD cases. Anwar Hussain sir was also there during those times. And we have done a lot of work regarding the investigation of school building at Puar. Then there is another hospital building at Cherengi. And those were all wonderful experiences. The problem which as a government servant we are facing is that already Biju has already talked about all these things. We don't have enough fund to purchase equipments. So that is one of the major problem that we are facing. Another thing is that whenever whenever we wish to purchase an equipment, we have to call for quotation, and always we have to go for the lowest quote. And unfortunately, the lowest quote will be made by some company which is not at all acceptable from the specification point of view. So all these things are major hurdles that we are facing. But even then, most often we are asked to investigate the quality of construction as well as the condition of old buildings, both from the consultancy point of view and also as part of investigation requested by the various court of practice. Now, I have a small question to Dr. Nivin. Usually when we take the core samples, we say that the L/D ratio should be between 1 and 2. And then only we will get the correct result. So recently there was a court case in which they have taken the sample having L/D ratio less than 1. So in that case, what should we do? Shall we reject the sample, or is there anything else we can do to check the concrete strength? Can you share your
sir, as per caudal condition, we cannot go for less than 1.
Yes, but unfortunately, they have taken the sample without knowing that the L/D ratio should be in between 1 and 2. So I am in a fix now because I am not able to find a solution for such a problem. Actually, it's a court case.
Okay, sir. So from the caudal point, it is not what, but if the sample size is bigger, maybe we can again cover it.
Yes, we can make it short, but unfortunately, this is less than 1.
Less than 1. If it is 20 mm again, we can go up to 75 mm, but this is risky. It's not possible that much.
Okay. Okay, again, thank you, Ajit sir, for inviting me to express my opinion. Thank you.
Thank you, sir. Thank you, sir. Thank you, Mr. Sir. Okay, let us start our doubt clearing session, please.
Hello, Ajit sir. There are some questions in the chat box. Can Nivin sir answer to this first?
Yes, I will do. I think I found some of the questions, but most of the questions are answered by Shankar sir wonderfully. So I don't want to cross over it. So one question asked by Vinod, that is that to observe, inspect loss of pre-stress in pre-stress beam to ensure that the structure is still in serviceable. There is a strain measurement equipment is there, but the reliability of that equipment is not that much accurate. You can only calculate based on the strain from converted to the loss only. But other than any corrosion or anything, we have radar technology, something like this available for precious cables. For the loss, it is only strain we can calculate it. Other thing which is not possible. Otherwise, we have to give sensors to early stage itself. At the time of construction end, we have to monitor. So we have to equip at the initial stage itself. And the rest, the questions asked by Ravinder Kaur Sadhu, I think most of those are answered by Shankar sir. He wonderfully give the opinions about all. That's all. If anything else you want to ask?
If the participants have any further questions, you can ask it now.
Otherwise, you can mail it to the turtle. They will mail me also. I will give the solution for that.
Sir, one more question from Amritpal Singh is there. So can you read it, answer it?
In case of the building that has remained column level reinforcement bars uncovered, but has been pending completion of 3 years, what specific test assessment should be constructed to ensure the structural integrity before proceeding the construction of the 3-story addition? First, you have to go for the check whether the structure is initially designed for the additional 3-story. After, then if the bar is, you have mentioned the bar is exposed, then normally if the exposed bar have some corrosion will be there. So what will happen that when a bar is exposed, it is to moisture, this corrosion will be, even though the remaining reinforcement is covered, but the corrosion will be extended towards the inner depth. So we have to check, monitor with the equipment whether how much extent the reinforcement is corroded. And if it is within the limit, you can go for remove the corrosion and you can construct it. Otherwise, you have to give proper solution for the removing the reinforcement. Maybe you have to chip down some portion of the concrete and you have to tie up with the new reinforcement cable. Otherwise, if it is lesser corroded, then no issues. You can remove the corrosion and you can extend.
So I think there is a question for me by Mr. Ravindra Kaur, that how buildings can be checked for stresses and loads it can take. Please explain how we can check whether we can construct one more floor on pre-existing structure. Because it is a big process, and I think it requires one class, and Turtle can arrange that. And first of all, we will study the plan and find the areas where chances of no success are there. Like we will check the width of masonry between doors and windows, or between doors and doors, etc. And we will find a particular point initially, and we will check the stress first. It is a somewhat big process. I think it itself, and I love to take that class also in immediate future. I think the organizers of this meeting take note of that. Thank you. Surely I will explain that at that time. Thank you.
Thank you, sir. Hope there are no more questions. Okay, the panel discussion and interactions. The panel discussion and interactions were very informative. And now I am to invite Engineer Shiju Chandran, our Technical Committee member AOEK, Thiruvananthapuram, to deliver the vote of thanks.
Thank you. First of all, I would like to thank Dr. Nivin Philip for such an informative lecture. And also, I express my sincere gratitude on behalf of the participants for Turtle Smart Solutions, ICI and HiveTech for jointly organizing this session with AOEK. And I also thank the panel members who has delivered wonderful information. Ajit sir, Anwar sir, Mini ma'am, Biju sir, Shankar, and finally Mitra sir. I also thank the participants also for their presence and interactions. Thank you.